Hello guys, in this video I'm going to introduce you to this new quantization algorithm which is called as Kiwi. It's a new plug and play 2-bit Kiwi cache quantization algorithm. Quantization in very simple words refers to a technique in LLM to reduce the precision of models parameters from floating point representation such as 32-bit float to lower bit representation such as 8-bit integer or even 2-bit as is the case with Kiwi. This process is aimed at making these models more efficient in terms of storage and computation, enabling them to be deployed on devices with limited resources or to improve their performance in terms of inference. For example, you might have seen me installing these models on my one GPU, or even I have tried out some of these models on my CPU. Now, as I said, a 2-bit KV or key value cache quantization refers to a specialized method of compressing the key value pairs stored in cache memory by quantizing each value to just 2 bits. This approach is quite useful in the context of LLMs where memory efficiency is critical. By reducing the precision of the stored values to 2 bits, it significantly decreases the memory footprint of the cache, allowing for a more efficient utilization of available memory resources. This form of quantization enables the storage of a larger number of key value pairs within the same physical space. But this can lead to a loss of information and potentially affect the accuracy of the computations using these cached values. But that is the whole idea behind quantization, in order to give us a leeway to try out these models on a limited resource system. Now, coming back to this Kiwi, this is quite interesting and novel approach too. They have also showed us this per token quantization and per channel quantization, and then also this pre-filled phase and decoding phase. Just to give you a overview of this, and I'll drop the link to this in video's description too. What is happening here is that, as I said, that efficiently serving LLMs require batching many requests together to reduce the cost per request. But yet the key value cache, which stores attention keys and values to avoid recomputation, significantly increases memory demand and becomes the new bottleneck in speed and memory usage. This memory demand increases with large batch sizes and longer context length. Additionally, the inference speed is limited by the size of KV cache, as the GPU's SRAM must load the entire KV cache from the main GPU memory for each token generated. That is where this comprehensive study on element distribution in KV cache of popular LLMs, Kiwi, helps out. Researchers who have created this, and I'll again drop the link in video's description, they have found out that the key cache should be quantized per channel. That is, group elements along the channel dimension and quantize them together. In contrast, the value cache should be quantized per token. And that is where they have developed this tuning free 2-bit KV cache quantization algo called as Kiwi. With the hardware friendly implementation, Kiwi can enable Llama 2, Falcon, and Mistral models to maintain almost the same quality while using 2.6 less peak memory usage. This reduction in memory usage up to enables up to 4 times larger batch size. So, and that overall includes this performance. It is still a project in progress. So, as far as I understand, it's not about the whole LLM, but about storing result of some of the intermediate steps related to attention mechanism in a context cache. And it seems that the size of LLM in the memory will remain same. You can start playing around with it. Uh, you can install it by git cloning this repo and then load this, and from there you can try out this llama 2. I will make another video where I'll show you how to do this and do the inference with this model, but that is for another video. For this one, I just wanted to introduce you to this Kiwi, which is a tuning free asymmetric 2-bit quantization for KV cache. I hope that you enjoyed it. If you like the content, please consider subscribing to the channel, and if you are already subscribed, then please do me a favor and share the channel and the videos among your network on your social media accounts. That would help a lot. Thanks for watching.